Imagine standing in your room right now. The ground beneath your feet feels incredibly solid, permanent, right? Well, it's actually an illusion. We live on a seriously dynamic, restless planet. And, sometimes that hidden reality makes itself known in the most terrifying way possible. Welcome to our explainer on one of nature's most awe-inspiring phenomena. Take January 12, 2010. The ground in Haiti violently shifted. And in less than one single minute, literally under 60 seconds, over 200,000 people lost their lives. Entire neighborhoods just vanished, and billions of dollars in infrastructure were wiped out. And the craziest part? This all happened because gigantic pieces of the Earth's crust moved just a few meters. Section 1. The hidden forces beneath us. So, what exactly is an earthquake? At its core, it's the sudden shaking of the ground, caused by the release of stored energy inside the Earth. Imagine the Earth kind of like a giant cracked eggshell. That outer shell isn't one solid, perfect piece. It's broken into these enormous, jigsaw-like chunks we call tectonic plates. And these plates, they are constantly on the move. Now, to understand exactly why they move, we have to look a bit deeper. We live way up top on the very thin crust, but right beneath us is the mantle, this massive layer of super hot, semi-solid rock. Intense heat radiating from the Earth's core drives convection currents right within this mantle. Think of a pot of boiling water moving pieces of pasta around. That exact same continuous churning thermal engine is quite literally what drags our tectonic plates across the globe. Section 2. How earthquakes actually happen. Okay, let's dive into this. It's a very methodical, mechanical process. See, tectonic plates continuously try to move past each other, but the friction at their jagged edges gets them stuck. So stress builds up. We're talking over years, decades, or even centuries here. The rocks literally deform under the immense pressure. It's exactly like stretching a thick rubber band tighter and tighter. Eventually, the stress just exceeds the strength of the rock. It violently snaps and suddenly ruptures. That massive release of stored energy blasts outward as seismic waves, which is what violently shakes the ground above. So an absolutely crucial point here is understanding exactly where this event happens. You probably hear these two terms thrown around on the news a lot. The focus, or hypocenter, is the exact point deep underground where that rock actually ruptures. But the epicenter? That's the point directly above the focus, right up on the Earth's surface. The epicenter is usually where we feel the most intense shaking and see the absolute worst of the damage. Now, while tectonic earthquakes, the ones caused by plate movement, are definitely the most common and by far the most powerful, they aren't the only type. Volcanic activity and massive cave-ins can also trigger quakes. But actually, get this, human activities like deep mining, massive oil extraction, and injecting wastewater deep into the ground can actually alter underground pressure enough to induce earthquakes. We are quite literally moving the Earth ourselves. Crazy, right? Section 3. History's harshest lessons. Modern history is absolutely marked by catastrophic seismic events that have forced humanity to adapt. The 2001 Gujarat earthquake in India highlighted the absolute necessity of earthquake-resistant construction. Then, the devastating 2004 Indian Ocean quake and the resulting tsunami showed us the desperate, urgent need for global early warning systems. Tragedies like Haiti in 2010 and Nepal in 2015 taught us so much about protecting vulnerable populations and our heritage structures. Every single one of these disasters serves as a harsh but vital lesson in survival. And then there's the 2011 Tohoku earthquake in Japan. It didn't just cause an immense and tragic loss of life, it unleashed a massive tsunami and a terrifying cascading nuclear disaster at Fukushima. The economic toll? A truly staggering $235 billion. That breathtaking level of devastation cemented Tohoku as the costliest natural disaster in human history, really proving just how incredibly fragile our modern interconnected world actually is. Section 4, the ripple effect. Now, what's really interesting about this slide is to really see these immense regional vulnerabilities, we just have to look at India's risk map. The country sits primarily on the Indian plate, which is continuously driving northward, aggressively colliding with the Eurasian plate. And that continuous collision is literally still building the Himalayan mountains today, as we speak. Because of this incredibly active geology, vast regions like Kashmir and Northeast India sit right in Zone V, the absolute highest seismic risk category. The geology there dictates a constant, everyday state of readiness. But this ripple effect also slams the global economy. When a major quake hits, global supply chains are instantly disrupted. Industries like tourism and manufacturing suffer immediately due to factory shutdowns and damaged transport routes. However, on the flip side, other sectors see a massive surge in demand than construction, structural engineering, and raw materials like cement and copper. It's an objective reality of exactly how global markets react, shift, and ultimately rebuild in the aftermath of massive seismic shocks. Section 5. Engineering Our Survival. And this brilliantly illustrates how modern architecture doesn't just try to rigidly fight an earthquake anymore. It's actually designed to flex and move with the earth. We use technologies like base isolation, where a building actually rests on flexible bearings. This allows the ground to violently move underneath it while the structure itself stays relatively still. We also use massive tuned mass dampers in skyscrapers. These are huge counterweights inside the building that absorb the sway. We are literally engineering our cities to dance with the earth rather than break against it.
But hey, brilliant engineering can only do so much, right? If the ground starts shaking right now, there is one universally recognized personal safety protocol you must immediately follow. First, drop to your hands and knees before the quake knocks you down. Second, cover your head and neck, ideally getting under a very sturdy piece of furniture. And third, hold on to your shelter until the shaking completely stops. Memorize the sequence. It is the absolute gold standard for survival.
Section 6. The Future of Prediction.
So, will we ever be able to predict exactly when the next big one will strike? Well, the short answer is, right now, pinpoint prediction of the exact time, location, and magnitude is completely impossible. The Earth's crust is just way too complex and deep. However, we are getting much better at forecasting, which is estimating the probability of a quake over decades to help urban planners. At the same time, we've developed incredible early warning systems. These networks detect the very first, fastest-moving seismic waves, instantly sending out alerts that give people a few precious, life-saving seconds to take cover before the really destructive shaking actually arrives. And we are actively revolutionizing disaster management way beyond just warnings. Tomorrow's tech is already being deployed today. We're using artificial intelligence for rapid damage assessment, flying drone fleets to instantly map destroyed areas, embedding smart IoT sensors directly into concrete bridges, and even using supercomputers to create virtual city simulations to test out disaster scenarios. Space-based satellite constellations are out there literally tracking the millimeter-by-millimeter deformation of the ground from orbit. It's truly amazing stuff. As we wrap up, let's look at a few mind-bending facts that really show just how much planetary power we're dealing with here. Did you know that some tectonic plates move about as fast as your fingernails grow? It sounds super slow until all that built-up friction finally releases. And the 2011 Japan earthquake? It was so massively powerful, it actually shifted parts of the country by several meters. It even altered the distribution of Earth's mass enough to slightly shorten the length of a single day on our planet. Just let that sink in. Earthquakes aren't just random acts of nature. They are the visible, incredibly powerful expression of a living, breathing geological machine. We cannot stop the Earth from moving beneath our feet, but armed with scientific understanding, robust engineering, clear safety protocols, and rapidly advancing technology, are we prepared for when it does? It's a question every nation, every city, and every single one of us really needs to answer. Thank you for exploring the incredible dynamics of our world with us in this explainer. Life Tales. Learn, think, grow.